All right, hello everyone. So in this video, we're going to be looking at this water tower application problem, as you can see here. So it tells us we have this water tower modeled by this two-dimensional figure beside it, and you can see it's composed of, it tells me, a hemisphere. So you can see the half of sphere at the bottom there, a cylinder, which is this middle part here, and then the cone at the top. So we have three basic 3D shapes here that we need to deal with. It tells me that C is the center of the hemisphere, so C is the center there, and then D is the center of the cone. So I can assume that this is half, and this is the other half for each of those. Okay, so it looks like everything's labeled. It tells I see the 8.5 feet there, the 25 feet there, and the 47 degrees there. So we want to find to the nearest cubic foot the volume of the water tower. All right, so let me clean this up a little bit and let's hop right into it. So I'm going to zoom in here. So using the space here, I think we should look at each of the three shapes individually, and then we could add all those volumes together. So let's work from the bottom up. I'll just go in the order it tells me. So it tells me the hemisphere, the cylinder, and then the cone. So let's follow that order. So we have the hemisphere, the cylinder, and the cone. Let me do these. I'll do these in three different colors so it's easy to follow along. So we have the cylinder in the middle there, and then we'll do the cone in green. Okay, so first thing we do is I'm going to write each of the formulas out so we could go ahead and substitute it. So I know a hemisphere. So the sphere formula I know is 4/3 pi r cubed. That'll give me the volume, and then it's hemi means half. So once I find that volume, we can divide by 2. Okay, for the cylinder, I know my, basically like a prism, the area of my base times the height. So since my base is a circle, that's pi r squared, and then times the height. Okay, so that's a pretty basic formula there, same as a prism, the area of the base times the height. So since the base is a circle, we'll use pi r squared. And then the cone I know is 1/3 pi r squared h. Okay, so basically like the cylinder, except the cone is only a fraction of it, right? So we have all this, we said 2/3 of the space is empty there, so it's only 1/3 of the amount of space of a cylinder. All right, so let's start off with the hemisphere, because I think it's the easiest formula of the three, because remember, for the hemisphere, all we need is the R. Once I have the R, I can simply plug that in, and we'll have our volume. Okay, so we have 4/3 pi. Okay, so the radius of the sphere I have right here. So this tells me is 8.5. So 8.5 cubed. So I'm going to type that on the calculator, and then I only want half of that. So once I have the answer, I'll do that answer divided by 2. So let's go ahead and type that in real quick. So I'll have 4/3. Use the pi bind. Then we have the 8.5. It'll go up, and then third. Okay, so that's the volume of the full sphere, and we want half a sphere, so I'll divide that by 2. So it looks like we're going to get about, and remember, we're not going to round early, we're going to keep everything until our final answer. So I'm going to leave this in the calculator, I'll just copy and paste it when we're all adding them all together. So I'll write the full thing there. Okay, so there's my hemisphere. Moving on to the cylinder. So we have pi. Okay, so notice for the cylinder, it tells me that C is the center here. So that means I know that the radius of this one would also be 8.5. If I look at my cylinder here, so the two circles, the radius of the circle would be 8.5 as well. So 8.5 squared. And then I need the height, which I know over here is 25. That's a 25. All right, so there's my cylinder. So let's go ahead and type that in. So pi 8.5 squared times the 25. Height there. Okay, so it looks like we get, and I'll keep the full decimal again, so 5674.50171. Okay, so 2 down, 1 to go. So let me clean up my diagram. So we're going to have to focus on this cone here. Okay, so looking at this cone here, so if I sort of three-dimensionalize this cone here. Okay, so notice we have the cylinder here, and I know the opposite bases in a cylinder are congruent, right? So this circle is congruent to this circle. So if the radius of this one is 8.5, which I know from the sphere here, from the center to the edge of the sphere, no matter where I am, is the same. So I know that this is 8.5. So the radius of the circle is 8.5. So I could go ahead and type that in. So 1/3 pi I could use the same 8.5 squared. However, I don't know the height of this cone. Okay, I know that this is 8.5, but I don't know that the cone is the same height. Right? It doesn't tell me anything about the height of the cone because the cone is separate from the sphere. I could just make a taller cone, right? So it has nothing to do with the sphere. So I want to look at what it does tell me about this cone here. So I notice it gives me that 47 degrees. And I know it also gives me this right angle here. So if I look at this triangle, well, we have the right angle here. So I know that's a right angle. We need to find the height. That's the only thing I'm missing from my formula here. We have everything else. I just need to plug in this height over here. Okay, so if I zoom in here, I need to find this height. So that's what I need to find. I'll put an H there. But remember, we do know that this is 8.5, right? We do know that the radius of these circles here is 8.5. And it does tell me, remember, D is the center. So D is the center there. So I know that D is right in the middle. So I know that's 8.5. So I think we are able to find this height, right? Because if I look at this 47 degrees and what sides I have in relation to it, I could set up a trig ratio here, right? So it looks like I have H is the opposite side and the 8.5 is adjacent, right? I don't have the hypotenuse there. So opposite adjacent is tan, right? So I could do tan of 47. Okay, and on your screen, I'm sorry, your paper, you can do it in, don't do it here, but you could write the work somewhere else on the paper where there's room. So opposite over adjacent, so opposite is the H and the 8.5 is my adjacent. Okay, so if I want to solve for H here, I can simply multiply both sides by 8.5, right? So I could do 8.5 times each side. Okay, so I could do 8.5 times the tan of 47. Okay, so it looks like we're going to get about 9.115. Okay, so that's going to be my height, which I can now plug in to my, and I wrote 9, I'm going to keep the full decimal, but once I type it in, so now we could find the height of the cone. So let's type this in. So I have 1/3. Okay, pi. Clear the backside. Okay, so 1/3. I'll go back up in a second and copy and paste those last ones. So pi, that 8.5 squared times, and let me go up and copy this full 9.115 in there. Okay, so it looks like for my volume here, we're going to get 689.6512.514. Okay, so if I want to find the entire volume, now I can simply just add these three together. So we found each of those three shapes. So I'm just going to plus them all together, which is easy because I had them all saved. So let me grab this 1286 here, enter to copy and paste it. Then let me do plus. Let me grab that 5674 right there. Enter again, plus, and then I'll grab the 689 here, plus there. Okay, so here's my final answer. And if I look at it tells me to round to the nearest cubic foot. Okay, so it doesn't want a decimal, it wants to the nearest cubic foot. So that 0.3 isn't big enough to round up. So it looks like 7650 is going to be my final answer. So 7,650 cubic feet will be my final answer. Okay, so you see it's a lot of work, but the calculator does most of the, I don't have to deal with rounding because I could just copy and paste it. So the calculator does most of the work for me. But especially with these multiple shapes, I would either draw an arrow, so you know which one corresponds to which, and do one at a time, and then it makes things a lot simpler if you sort of divide it and focus on one thing at a time. All right, so that is all for this video.